The rest of this chapter is going to be about logarithms, and you have to know how the logarithm equation works, because since logarithms are hard to think about, it's easier for you to think about exponents. So when you see a problem that looks like this, log base 2 of 8 equals x, until you're to the point that you just know that this number right here is the exponent. So when I look at a log, I just think, oh, what's the exponent? It's 3. But until you get to that point, you might want to translate that into 2, and we're looking at the base of 2, to what power equals 8. And from there, at least for the first 8, you should be able to do it in your head. 2 to the third power is 8, so x is equal to 3. Since most problems in the natural sciences involve the natural base, you'll also have to be aware that when you see an ln like this, an ln really means log base e. So if you were to see a problem that said, let's say log base e of e, what that would be saying is, what's the exponent? It would be saying e to what power is equal to e. And the answer to this problem would be 1. E to the first power is equal to e. You also have to recognize that when there's no base, like when you look here, there's nothing written here, it means common log. And common log actually means that you're dealing with a base of 10. So logs have invisible tens. And so when you see a problem that looks like log of 100, it's really just saying 10 to what power is 100? And the answer is 2. And if you see a problem that says log of 0.001, this is saying 10 to what power is 1/1000th, and that's a little bit trickier because you have to cube the 10 to get 1,000, but the exponent has to be negative to flip it to the bottom of the fraction. And then you might wonder why we're doing this. Logs and exponents are inverses, and we use logs to solve a problem where the exponent is the variable. So let's take a look at that. Like this problem right here, the exponent is the variable, and I have to think to myself, well, 2 to what power is 4? And I can probably do that in my head as x equals 2. And you can also probably do this one in your head. This says 2 to what power is 8, and x is equal to 3, because 2 to the third power is 8. But numbers aren't always going to be that simple. Here's a less simple problem. This says 2 to what power is 5, and we know it's probably between 2 and 3, but we don't want to know exactly what it is. So we're going to rewrite this as log base 2 of 5 equals x. Now, do you remember how to type that in on your calculator from Algebra 2? If you don't worry about it today. We're going to cover that when we get to calculator problems in the next video. The most important thing you need to remember about logs is when it's giving you a log problem, it's really asking you what the exponent is. So when you see this problem where it says log base b of 1, it's really asking you b to what power is equal to 1? B to what power is equal to 1? And if you can think of it like that, you'll go, oh, well, anything to the 0 power is 1, so it's 0. In the next problem, they're asking you b to what power is equal to b. And anything to the first power is equal to itself, so the power is 1. The next question is saying, and you're looking here at I'm going to color this in blue, b to what power is equal to b to the y? Because in this problem, like the b to the y is the answer part of the problem. So it's the blue b to what power that we don't know is equal to b to the y. And when you see them lined up like this, you're like, oh, answer's y. b to the y power would be b to the y. You can think through this next problem the same way, but at some point, I think it's just better that you internalize that a log and an exponent are inverses. Kind of like multiplying is the opposite of dividing, adding is the opposite of subtracting. So if you have b to the log base b, these guys just completely cancel away because they're inverses, and the answer is just equal to x. Now, you could write it like this. This b is the base, so it's log base b of this x right here is the answer, equals log base b of x. And so the answer is x, but it's probably easier just to imagine, oh, well, right here, I know that the b and the log base b cancel, and so it's just x. Then you'll hit problems that you just feel like they're trying to torture you with. They don't tell you what the base is. And so you need to know that if there's no number, like there's no base, that the problem is a common log. And anytime they don't tell you what the base is, it's actually 10. And so the first question is just saying 10 to the 0 power is 1. And then the second question, you'd have 10 to the first power is 10. And if I wanted you to figure out, let's say, the log of 1,000, you would just think to yourself, well, 10 to what power of 10 do I get to get 1,000? And that would be 3, because 10 cubed is 1,000. If you see an ln, that's a secret code word for natural log. And so there's really also a missing base written right here, and the missing base on an ln problem is e. So this is a natural log, and so if you imagine anytime you see the ln, that there's an e there, this problem would be e to what power is 1, e to the 0 power is 1, and the next problem would be e to what power is e, and e to the first power is e. We're going to start off with pretty easy problems where you just have to say what the exponent is. So when you look at this first problem, this is asking you 4 to what power is equal to 8. You're going to think your way through it. You're going to need to square root the 4. That'll give you 2. And then you're going to need to cube the 2, and that will give you 8. And the thing that you need to know about exponents is the negative in an exponent is the part that flips it. And the top part of an exponent is the power, and the bottom part of an exponent is the root. And so if I'm saying 4 to what power is 8, I need a root of 2 and a power of 3. And nothing gets flipped, so this answer is just 3/2. Log base 4 of 8 is 3/2. And the next problem, they don't tell you what the base is, therefore it's a common log, which is a secret invisible base of 10. And so this problem is asking you 10 to what power is equal to 1 over 100. For this problem, you're going to need to do two things. You have to take the 10 to a power, and in this case, the power of 10 would be squared, because I'm going to have to square it to get 100, so I would need the power. But then I also need the 100 on the bottom, so I need to flip it. Flipping is a negative exponent, so the answer to this question would be x is equal to -2. The 2 squares it, the negative flips it. If you have a problem like the next problem, log base 2 of 1/8, you're going to look right here. What do I have to do to a 2 to get a 1/8? Or in exponent form, 2 to what power is 1/8? And if you think your way through it, you're going to need to flip it, so it's going to be negative, and you're going to need to cube it, so it's going to be cubed, and so the answer for log base 2 of 1/8 is -3. Again, every time you see a log, you're going to think in your head the answer is the exponent. So on log graphs, if you're super smart, you just be like, oh, logs are the inverses of exponents. So if the exponent looks like this, the log looks like that. But if that doesn't come to you quite as easy, you're going to have to do log graphs by figuring out what the exponential graph is and then doing the reverse of it. So let's take a look at it that way. If I rewrite this as 2 to what power is equal to x, it's kind of weird, but I'm going to be plugging numbers in for y instead of x because it's an inverse graph. And so if I take 2 to the negative 2 power, I get 1/4. And 2 to the negative 1 power is a half, and 2 to the 0 power is 1, and 2 to the 1 is 2, and 2 squared is 4. So this graph has a point at 4 and 2, and it has a point at 2 and 1, and at 1 and 0, and at 1/2 and negative 1, and there's your graph. Much more accurate than my purple sketch. And you also need to note that this graph has a vertical asymptote. So if you're going to write the limit notation right here for this green section, it would be the limit as x approaches 0 from the right of the function is negative infinity. This limit notation is easier because this is unbounded, and so it just goes to infinity as x goes to infinity.